Amelia McNamara is an assistant professor of statistics in the Department of Computer and Information Sciences at the University of St. Thomas. She holds a BA in English and Mathematics from Macalester College and a PhD in statistics from UCLA. Her research focuses on the impact of computational tools in doing and teaching statistics. We're really happy to have Amelia back this year, fresh off a talk from USAR. So with that, I'll turn it over to Amelia. Thanks.
Great, thank you. Can you see my slides? I see some nods, cool, thank you. Oh, this is maybe in the way, let's not do that. It's always just like a little bit hard. Well, I'll try not to get too distracted. Oh gosh. Sorry, there we go. All right. So like Lindsay said, I'm Amelia McNamara. I'm going to be talking about scraping and iterating and purring. I teach at the University of St. Thomas in the Department of Computer and Information Sciences. And I tweet at the handle Amelia MN. That's a double entendre because my last name is McNamara and I live in Minnesota. And I just tweeted a link to the slides if you want to follow along. Though there is an R Markdown document in the main conference GitHub page, but I used Zarangan slides. So if you don't have all the JavaScript libraries and CSS and everything, it doesn't render. So if you really want to see it beautiful, you should go to my website. And I'm realizing that I didn't put in my land acknowledgement slide, but I just want to start by doing a land acknowledgement. I am in Minnesota, I'm standing in Minneapolis right now, and I'd guess that many of you are also here in the Twin Cities, and I just want us to acknowledge that the history of the land here says that, you know, this land was taken from indigenous people, Dakota people specifically. We still have a really vibrant Native community here, and I would just want us to keep that in mind, even though we're not together physically in some space, but sort of think about our physicality. Let's see. Does that work? Not quite. There we go. So I'm going to be talking about iteration in this talk, and I'm going to be talking about iteration at two different levels. So I went and grabbed the definition from the Merriam-Webster dictionary, and the two definitions that I'm going to be talking about are, oh, why did that happen? Are repetition of a sequence of computer instructions a specified number of times or until a condition is met, and the idea of a procedure in which a repetition of a sequence of operations yields results successively closer to a desired result. So I'm going to be sort of talking about these two different levels of iteration. And I just want to start with a couple basic R iteration ideas. I'm going to use the penguin data from Alison Horst to demonstrate this. And the data comes with bill lengths of all the penguins in millimeters. But let's say that I wanted to know the bill lengths of those penguins in inches, because I'm American. So there's different approaches that I could take. And if you were coming into R from a language that was not R, like Python or something else, your first impulse might be to use a for loop. So that's an iterator where you're doing steps successively in a computer. And I could do something like this first code chunk here, where I'm gonna say, you know, for I in 1 to the number of rows in penguins. What I'm going to do is I'm going to take the bill length in millimeters, I divide by 25.4, and I'm going to assign that into the bill length in inches for I. But that's super inefficient. R has this copy on modify thing, and so that would be a really bad way to do this operation. So instead, I should do something vectorized. I don't need to iterate over every element. I can just say the bill length is in inches is equal to the bill length in millimeters divided by 25.4, and R is going to do the same thing to every element of that vector. So that's one idea about iteration. Another idea, and this is a quote from the R for Data Science book, is that if you start repeating yourself in programming, you should probably fix that. So if you've copied and pasted a block of code more than twice, R for data science says you should consider writing a function. I sort of think if you've copied and pasted the code a couple times, sometimes there's a more efficient way to do it. And you could look at that first. Maybe you're going to make a function eventually. So I grabbed this example. I'm really interested in R syntax. So this is from my syntax comparison cheat sheet. And I gave a keynote talk at USAR last Thursday. So if I was going to take the mean of the body mass in grams for each of the different species in the penguins data, I could, copy this code 3 times and just change the species. Or a more efficient thing that would avoid copying and pasting would be to use a tapply, an apply function, in this case, a tapply. I can never remember the tapply or any of the apply syntax really, so it always takes me a while. And so another solution that you could use, which is maybe more readable, would be to use dplyr, penguins, then group by species, then summarize the mean of the body mass in grams. So that's more simple for me to think about cognitively, but it's less efficient in compute time. So these are the kinds of things that you need to think about if you're going to be doing some operation to data more than once. So those are some simple iteration ideas. But I mostly want to spend my talk today talking about more complex situations because there's lots of other places where repetitive code might come in. And specifically, I'm going to talk about some scraping projects I did in the last year. So I'm going to talk about a scraping project from GitHub and another one from Facebook, and hopefully show you how you can iterate in code and iterate in your process. So the first project was counting GitHub commits. I taught this class in spring semester 2019. It was sort of an advanced R class, and I had students using Git and GitHub. So GitHub sent me this swag bag to distribute to my students, lots of stickers and handouts and all kinds of stuff that there was enough for everyone, but then just 2 t-shirt redemption codes. And so I told my students, I'm going to give a t-shirt to the student with the most commits over the semester. I had 2 sections, so 1 shirt for each section. And I just said that assuming that it was possible to get that information, but I didn't try it out until the end of the semester when my students started saying, yeah, who won that t-shirt? So one approach, which I didn't use, would use the GitHub API. So you could hit the GitHub API and ask it for some information. Sadly, the API is not going to give you the number of commits for a user. All it will give you is the number of commits for a repository. So I could have gone to each student and found all the repositories they had, and then gone back to the API and for each repository figured out the number of commits, and then for each student added up the commits by the repositories that they contributed to. But it sounded like a bad approach because it would be a lot of iteration. And then there's like some problems with just counting the number of commits in a repo as the students' commits. If they committed to something with a lot of commits, then their account would be artificially inflated. And in fact, I was having students work in groups on projects, so I wanted to count their own commits, not all the commits from their whole group. So what did I do? Well, if you don't have an easy way to grab the data, like from an API, you might scrape data. And so that's what I chose to do. So if you go and look at someone's GitHub profile page, you might see this number that I've got circled here where it says 411 contributions in the last year. I've actually committed more since I took this screenshot. But I decided I was just gonna go grab that number where it says 411. And if you're going to do scraping, the first thing that you might want to do is go look at the page source of the HTML page. So scraping is basically just like parsing text data, usually HTML text data. So in whatever browser you're in, you can go to view source and see the HTML. So this is the HTML for my GitHub profile page. And you can see in that code, it says 411 contributions in the last year. Okay, cool. So I'm going to try and scrape those numbers for each one of my students. I'll say I wrote a blog post about this if you want to read more about it. It's up on the Teach Data Science blog. I'm sort of picking on the other blog authors here, Hunter Glantz, Joe Harden, and Nick Horton, because I can't actually show you my students' GitHub usernames because of FERPA issues. So the blog post really shows how I would parse the student data and get it into this format. But here we've got a little tibble, which is a bunch of people's GitHub URLs. And then I'm gonna just get myself set up to scrape. And I'm gonna use the rvest package. So we're like sort of harvesting data, I guess, rvest. And I would really recommend, if you're getting started with this, to look at the webinar materials that Garrett Grolmand has put together. Those have been really useful to me. So right here, what I'm doing is I'm setting up an HTML session. Technically, for the code that I'm going to run for you live in this presentation, that's not technically necessary, but when we get to the end, I'll give you some ideas about some of the complicated pieces, why I really needed that HTML session. So then if I want to scrape that number, that 411, which has now changed, I could use this function that, that I've written, where I take a session and then I jump to a particular URL, a GitHub URL. I read that HTML, and then I get the HTML nodes that match h2.f4.textnormal.mb-2. Then I get the HTML text from that node. Then I pluck out the second thing because it's sort of different lines of data. And then I parse out that number. So that's a function that would find the number. And that's something that I want to iterate over. So that's just to do it one time, but I want to do it many times. Oh, just a little aside, it's really hard to figure out those selectors like that h2.f4, right? It's hard to see that in the HTML. So I would recommend the selector gadget, and there's some documentation for that linked on this slide, which will help you figure out the exact selector that you need. Okay, so I had that function, which was called commits, and I wanted to do that for every single URL. So I could have written a for loop, and in fact, that's what I did initially, is I said for I in 1 through the total number of students I had, just go through and do that. But that's really inefficient, so it's more efficient to use a map function. And these map functions come from the package purr. I realized my talk title should probably have one more R because it's from the purr package. And you know, there's a cat hex sticker because there's lots of cats in R. We've got R cat ladies and all these sorts of things. So that's the purr package. And the power of the purr package is really these map functions. So map DBL or map double is one of the map functions, which is going to return a vector. So in this case, it needs to be inside a mutate. This is what I always have trouble with purr, is whether the map function needs to be inside a mutate or if it can just sort of like be by itself in a pipeline. But in this case, it needs to be inside. So I'm going to take my roster and I'm going to pipe it into a mutate where I'm going to say commits is the map double of the URLs from my roster, and I'm going to map over that function commits, and I'm going to feed it in the session that I had initialized a couple slides ago, and then I'll just arrange them in descending order of commits. So if we look at this, you can see when I last ran this code, I actually had 418 commits, and that's probably gone up since then because I committed this. But it looks like Nick Horton would win the t-shirt. And there's a few more things in the footnote here. So there's links to the purr package, and then there's a great package tutorial by Charlotte Wickham. Charlotte is a total expert in purr, and actually she helped me by refactoring this code. So I said I had a for loop in my code originally, and I just couldn't figure out how to get it to work. And so I know Charlotte, so I reached out to her and I said, would you help me? And so she helped me make the code better. So this is pretty good. Nick's winning the t-shirt, but there's like two problems here. One is I didn't say I was giving the t-shirt to the person with the most commits in the last year, and that's what that 411 or 418, whatever it is, that number is last year. And then most of my students' commits were on private GitHub repos, which are visible to me because I'm their instructor and I'm on the repos, but it's not visible on their public profile pages. So I'm going to start by solving problem 1. And I've got another little aside here. If you use GitHub and you want more green squares on your profile page, you can change your contribution settings to show private contributions. I do a lot of private repos, so I've turned this on so that I have more green squares. But my students hadn't done it, so I needed to be logged in to see their true commit counts. So that's part of the reason why I had this session. So instead of just scraping that 411, what I decided to do was scrape those green blocks. They actually have data attached to them. So if you look at the source code for this page, you can see each one of these is a rectangle, and it has things like data count equals 0, data count equal 5, data count equals 0, and that's the number of commits that I made on those days. So I could do something pretty similar to my first function, where I'm gonna call this function commits by date, and that's gonna be a very similar thing. I'm grabbing a different HTML node, in this case, rect.day, and then I'm getting out the attributes, not the text. And then again, this was generously refactored by Charlotte. I have a map function here. This is a map DFR, a map to a data frame, where I'm taking the data and I'm making it into a list. And then this is gonna allow me to do some of the selecting and mutating that I wanna be able to do. So that's kind of the main scraping code. But of course, then again, I need to iterate over the URLs. So I've got one map function already inside my function, and now I'm gonna have another map inside this mutate. So I'm gonna say by date is a map of the URL over that function, and I give it the session again, and then I need to unnest it. So this was another sort of tricky thing. And then there's some data wrangling. I'm gonna filter the dates to be within the range of the semester. I actually changed them to be 2020 because you only see the last year, and I had 2019 and it was not working. So if we do this, it looks like Nick Horton is still gonna win the t-shirt, but he has many fewer commits that were sort of in the range of the last semester, only 509 compared to whatever you had before, 1,800. And I have 88 instead of 418. So this was more the way that I actually wanted to do my code in order to give the t-shirts to my students. There's another wrinkle here, which is the authentication. And so, like I said, when I went to my students' GitHub pages, it often said like 0 commits because all of their commits were on private repos from my GitHub classroom. And so in order to actually get the data, I needed to be logged in. And RVest will let you do this. If you have an HTML session, then you can do these things where you like find the form on a login page and then you set values. So in this case, your login, mine would be, you know, in quotes, Amelia MN, and your password is, in quotes, whatever your password is. So I'm obviously not gonna run that here because I'm not gonna give you my GitHub password. But again, you could set that up and then you would start sort of like a new session, which would be a submit form of that login information. And then you could read the HTML. And then sort of from there, it's gonna be very similar to the kind of scraping that I already outlined. So like I said, all that code is available on the blog post that I wrote. Some code that is not available on the blog post is my original code that I really used when I was trying to figure out who won those t-shirts in the last week of the semester. And Charlotte helped me refactor this. So this code is really ugly and it's really slow. So you can see there's a for loop. That's probably a bad sign. I've got a map in there. I did, you know, figure out some maps, but I'm mapping in a strange way. I have to spread something. I'm doing a a count where I'm pulling something. And then if you look at that bottom line, I'm printing a period for every iteration of the loop, just because it went so slowly. I like to be able to see like, oh, it did a student, it did another student, it did another student. It was incredibly painful for this to run. So my point here is that perfect code doesn't flow out of my fingers. It doesn't flow out of really any programmer's fingers. And so if you're not happy with your code at first, you could try again. So this is the other kind of iteration, the, sort of trying to get successively better until you approach the right solution. We call this refactoring in code. So that's the process of turning working code that is maybe ugly or inefficient into code that works the same way, but is better, faster, cleaner, whatever. So you could refactor your own code, or you could have a peer do it. Like I had Charlotte do the refactoring to help me with that. And Jenny Bryan had tweeted this blog post from GPA Hill, which is refactoring pro tip, easiest, nearest OWI first. And he is explaining his strategy for understanding code by refactoring it. So when he sees code that he doesn't get, he changes it until he gets it. So he says the trick is to narrow your focus until you find a line or two that on the one hand you can understand, but on the other hand takes you a reading or two to get. In other words, though graspable, it's not readily so. Then you fix it. Then you try again. Find a tiny thing, fix it. Find a tiny thing, fix it. And he says two things occur, one straightforward and one remarkable. The straightforward thing that occurs is that I gradually gain some modest understanding as I work. And the remarkable thing, the search for easiest, nearest OWI starts returning different results. So you start seeing things that you hadn't seen before. So I would really recommend trying to iterate on code in this way to help you gain better understanding of coding. The last note from that footnote is the EIKIFJB acronym, which I just learned about last week. That's the Everything I Know I learned from Jenny Bryan. And there's apparently hex stickers, so I'm hoping to get one of those because, yeah, really, everything I learned from Jenny Bryan. Everything I know. All right, so that was my GitHub scraping project. And I had another scraping project in the last year, which had to do with Facebook. So in October 2019, I decided that I was gonna delete my Facebook account. And this was like a huge decision for me. I was addicted to Facebook. I had used it every day, multiple times a day since I got my college email address in 2006. And actually up until the point when I deleted it, I just kept looking at it. And I think Facebook is super useful for a lot of people. It brings together people who have rare diseases across the world. It helps you stay in contact with your family who's maybe geographically spread out. It's a way to, catch up with friends, things like this. There's, political organizing that takes place on Facebook. But I talk a lot about algorithmic accountability, and I think that Facebook has just been a bad actor again and again and again when it comes to using data and protecting people's rights. So I wrote a blog post when I deleted Facebook, which had some examples of why I was deleting it. So like their discriminatory housing advertisements are one example. And again, I wrote this blog post 9-ish months ago. And Facebook has not turned it around since then. I actually found all 3 of these bullet points are from the last week. So in July 2020, Facebook's own civil rights auditors say its policy decisions are a tremendous setback. Facebook engages in online segregation and redlining through discriminatory advertising. And then a blog post by Hypervisible, Facebook cannot separate itself from the hate it spreads. So I'd really recommend, if you want to know more about Facebook and tech ethics, Hypervisible on Twitter, forgetting his real name, is super great. So that's where I get a lot of my news. So I think that Facebook is pretty evil. I'm not going to judge you if you're going to keep using it. I think, again, there's good things about it, but I decided that I was done with it. But the problem was that I was so addicted to Facebook, and I'm kind of a data hoarder. So I don't want to let go of my data. I knew that Facebook had all kinds of data about me, and deleting my Facebook account felt like letting go of data that I wanted. So there are easy things to get from Facebook in terms of your data that don't require scraping. So there's links in my blog post to where you can go to get these data downloads, but you can go and download your photos, your friends, your messages, your posts, ads, comments, search history, all kinds of stuff. And you can choose either a JSON or HTML format. I actually grabbed both of them. I think the HTML is the one that you would recommend that your dad download to be able to, sort of navigate around. The JSON is the one that you want if you're actually going to parse the data. So I did some parsing on my friends from the HTML, and that was way more headache than it was worth. So I think it would have been really easy if I had used the JSON version of my friends list. So some data, just really easy to get from Facebook. But there's a couple notable pieces that Facebook does not want to give you. One thing is tagged photos, and the other one is your friends' birthdays. So it used to be possible to export ICS, I think a calendar file of your friends' birthdays from Facebook. And then Facebook decided that that was not data that you really owned. Even though you can see the reminder every day for someone's birthday, it sort of belongs to them, and so you can't have it. And so I really wanted both of these things. Tagged photos, I knew that my friends had put up photos of me that I wanted to keep, and I have just a terrible memory. So I knew that I was never going to remember anyone's birthday if I didn't get the data somehow. So I went out on the web, and it turns out there are Python scripts to help you get both of those things. And I got the script that grabs the birthdays to work, but the scripts that I tried in Python to get the tagged photos, I just could not get a single one to work, and I'm not a big Python person, so I couldn't debug them. So I wrote my own scraper in R. So again, before you're actually going to scrape something, you have to get set up to scrape. And in this case, I'm using the package R Selenium, which is, Selenium is a way to drive a web browser programmatically. You can drive a Firefox browser, Chrome browser, maybe Internet Explorer, I don't remember. And it's kind of a strange thing. It's actually going to pop up a window like a web browser that you can see as you're sort of working with it in R. I'll warn you, it's hard to get it installed. It took me quite a while to get it working on my Mac. It needs Java. There's some other dependencies, so it's not as easy as a regular R package. But I tried many other ways to do this scraping, and nothing worked. So here I'm loading the library, I'm starting the RS driver, I want a Firefox browser, and then there's you have to get the client, I don't really know what that is, but then I'm gonna navigate to facebook.com. And then again, I would need to put my login and password here. I'm not going to put my password here for two reasons. One, I don't want you to have my passwords to anything. And two, I deleted my Facebook account last October. So I actually don't have an account. But my partner was very generous in letting me use his login to check that this code still works. So I'm pretty sure as of yesterday, this works on my computer at least. And then again, you're going to sort of find these elements. You're going to find the email, the password, and the login button, and you're going to send some information, and you're going to click that button programmatically. And then there's some getting set up to scrape. If you're going to get the photos of yourself, you need to navigate to that sort of landing page. Again, for my demo, I used the R Ladies Global Photos, which is a slightly different URL format, but you're going to navigate there. And then if you want to do this all programmatically, you're going to find the first thumbnail and click on it. And I have a video that I'll show in a minute of me scraping the Our Ladies Global photos, where I actually just clicked on it physically with my mouse because I couldn't figure out what element I really needed to click on for group photos. So then here's some scraping, and I have this in quotes because this is like not the way that you usually scrape data. And you can tell that it's inefficient because it's got for loops. So I'm gonna try and find the SRCs, the like sources, the links basically to all of the images. And the way that I did it, and you should refactor my code if you're out there, I think that would be a great exercise, is I set up a character vector that was 5,000 long, because I figured there's no way there's more than 5,000 tagged photos of me. I don't know how many there are, but no more than that. I actually made this a little bit better when I was looking at the code yesterday. So I have two little for loops. I do the first two. So I find the spotlight element, I get the SRC, the link to that image, and then I find the next thing, the next button, and I click it. And then I do that again. I find the SRC, I save that, I find the next button, and I click it. And then I'm going to do this again, 5,000 times. When I did this for real with my own data, I sat there, and you'll see when I run the video, it actually clicks through, and you can see all the photos like sort of going by. So I just sat and watched until I noticed that it had gotten back around to the top, like the newest photos, and then I just clicked the stop button in my console. So again, like lazy programming. Here, this is a little bit better, where I said if the URL, the source for the picture that you're looking at is the same as the one from the first picture, then stop. So that's maybe a little bit better, but you could do a much more efficient thing here. So I do want to show you a video. I think it's going to be easier if I show it locally on my computer. So I'm just going to share something different. Basic. Oh, I minimized it and then it doesn't know about it. Is that true? Can I not? Oh, there it is. QuickTime Player. Optimize screen share. Okay. So this is just a quick little screencast video, and I think I've got the volume down so I can just talk over it. So again, just loading the packages and then getting this driver to pop up. So you can see it says it's connecting, and now a Firefox window shows up. There's like a little bit of getting that client, and then I'm going to navigate to facebook.com. So that's going to actually, in that browser window that's popped up, it's going to go to Facebook. And you can see it here in a second. There's a little robot icon up in the URL bar, but it actually went to Facebook, and then it's sending that login. So that's good. Then I'm navigating to the Our Ladies Global page so that I can look at those photos. And then I think I move some of my windows around so that I can see both things at once. Yeah. So then I'm just sort of lazily clicking on the first photo because I couldn't figure out what element I needed. So I'm going to skip that code, and then I'm going to run this, the first two. There's actually only 3 photos here, so it stops very quickly. But that gets me all those links to the images. And then there's actually a little bit more is to actually sort of clean up that data and save the list of URLs. Like I said, there's just 3 for the Our Ladies. So I saved those URLs and did the downloading as a separate activity. Then you need to close that, that browser, and this process just never quits on its own. So I have to go into the activity monitor to get it to quit out. And then here's where I actually download the images. For my own Facebook, I had 878. In this case, we just had 3. But then if you go into your, wherever you said to save them, I put them in the IMG folder. There's a photo of some Our Ladies. Let me get back to my slides. advanced portion of screen. Let's not do those things. Share, and then close this. All right. So that's kind of how it works. So those last few steps, there was a little bit of data cleaning, the closing down of our Selenium, and then actually doing the downloading of the photos. That downloading of the photos thing, I've got a for loop again. That one I'm pretty sure could have been vectorized or made into some kind of map statement. I tried again, and then I just lost interest. I had the photos, it worked, and so I moved on. So like I said, that code is really hacky. Sort of popping up a browser and then having it click through and then get all those source URLs, that's not really scraping. Scraping is usually more like looking at an HTML page and then getting a bunch of information. So this felt kind of strange to me. I was planning to refactor this code before my talk, but it didn't end up happening. A few little things happened in the interim, but maybe you want to try and refactor it and keep in mind what GPA Hill says. I will say that this, in terms of kind of like iterating and trying to get closer to the final product that you want, I did have many failed attempts before this one that actually worked. So I've removed it from the GitHub repo, but you can look back in the Git history, and I had this file called useless scraps, which is where I put code that didn't work, but I wanted to keep just in case I needed to come back to it. So I tried doing the scraping with rvest, the same kind of way that I did with GitHub, and that did not work. I tried a bunch more complicated Selenium things. I tried this package Splasher, wasn't able to get any of those to work, and then came back to Selenium and was able to get this kind of hacky solution. So you could go look at those. Maybe one of those could be refactored into something that works as well. So my basic point is that when you're programming, there's kind of these two things that you can think about in terms of iteration. One is the repetition of a sequence of computer instructions until a specified number of times or until a condition is met. That's like compared to recursion in this definition. So that's things like for loops or apply statements or map statements. And then there's the higher level thinking, a procedure in which repetition of a sequence of operations yields results successively closer to a desired result. So that's kind of like iterating in your own process. That's all I had to say. So thanks so much for your attention, and I'd be happy to take questions.
I'll clap for you, Amelia, since I'm the only one unmuted.
Thank you.
I think everyone is clapping.
Oh, I see the little icons. Cute.
Yes. So I will start with a couple of questions. So Michael Beckstrand wants to know, is there a difference between a for loop and per map when you're going to URLs, jumping to separate URLs in an HTML session? That seems to be a series of serial actions. And maybe you could just comment generally on like the for loop versus map approach.
Yeah, so I will admit that I'm not like a super expert on this. I do believe that the map statements are much more efficient. They are basically like apply statements, but they're like maybe more general. So I don't think that the map is doing things sort of like one at a time. I think that it's kind of doing things in parallel. And I know that there are some extensions to per that actually do like real parallelization, like if you had multiple cores or something on your computer. So the map should be much more efficient. I think I actually did the system time on a couple of those, and it was pretty different.
Great. So the next question is, I think probably things that anybody has experienced when they try to do web scraping, that GitHub maybe wrote its HTML to be easily understandable, but what would your approach be if it was obtuse, like for instance, of the color, but not the number of commits, or maybe things that weren't very regularized?
Yeah, I mean, I think with the GitHub example, if those little squares had not had the data, I probably would not have tried to scrape the squares and then back calculate like what the numbers probably were from the colors. And I might have gone back to that API and tried to do something, you know, with those other levels of recursion. I think, you know, the selector gadget is a pretty useful tool if you're going to be doing scraping. Like you can open it up and you can click on things that you want, and then you can click on things that you don't want, and it'll help you figure out like a really long selector that'll select, you know, these tables but not these ones. I have had some times when it's really hard, you know, you end up getting sort of gobbledygook that you don't want along with the stuff that you really wanted to scrape, and then you end up doing a lot more data cleaning. So I think it does kind of depend on how nice the HTML is. But honestly, if it's, you know, some professional website, the HTML is probably pretty structured. It's maybe being generated by, you know, something like, I don't know, Jekyll is something that I use to generate my static site, and I know people use like Blogdown. I think that those kinds of tools are creating HTML that's pretty readable.
So I think the next question is a little bit in the same vein, but see if you have anything to add. How would you go about using mapping functions if some of the pages did not have the data you were looking for?
I'm not sure I completely understand the question. So maybe I can share my screen again for a second and go back to a slide. So like here, where I was iterating over these URLs, I'm mapping those URLs, which are, I made that list of URLs. It's all of my students' GitHub pages. So I know that there's going to be data there. And then I'm applying that, that function from the previous slide where I'm, you know, doing a session, I'm jumping to the URL that I told it to jump to, and I'm getting this information about the numbers. So I guess I'm again, not a purr expert. You should go watch Charlotte Wickham's talks if you really want to hear the expert. But I think that the purr stuff does a pretty good job of handling missing data. So I don't think it would just you know, kind of quit out on you if there was a page that didn't have what it was expecting.
All right, there's one more question, but I think it's probably best solved with maybe a link. I think we will let Amelia go and give everybody about 7 minutes of break here. So thank you again, Amelia. Great talk.
Thanks for inviting me.